Robseco Future Farm. Today's innovations, tomorrow's solutions.
Hello and welcome back to the Robseco Future Farm. I'm your host, Jim Robinson, and it's just me today. Today we're going to be talking about what humans, chimpanzees, and corn all have a bit of common, or how they might relate to each other. So what we're going to talk about specifically is going to be genetic diversity in corn. And I mentioned humans, chimpanzees, and corn, and I always think it's the most fun fact within all of the seed business that we can talk about how different two different hybrids may be from each other, or two different corn plants may be from each other, and how they may be more different genetically than humans are from chimpanzees. And so if you think about it, humans and chimpanzees share about 98% of their genes together. With corn, it's a lot more diversity than what we find in humans and chimpanzees. So if we think about humans, we have 23 pairs of chromosomes, so 46 chromosomes in all. In corn, it's 10 pairs of chromosomes, and corn has 32,000 genes across about 2 billion base pairs, whereas humans have 20-ish thousand genes across 3 billion base pairs. So it's a lot of genetic diversity and difference between the two. And what that ultimately results in is substantial differences in the phenotype of what corn may look like in the field and how it may perform. And so if we think of what that means, we can think about a couple different phenotypic structures of the plants. So right now, it's a great chance to start looking at differences in what corn looks like in the field, starting with the tassels, which is the easiest to spot right now as we're starting to get into tasseling. So we have these hybrids such as this one. This would be RC6516, 115-day hybrid. And you can see that it has a lot of large tassels that branch off and actually start to droop as they come over to the side. So you get this kind of spread out look of the tassel. As opposed to a 110-day hybrid, we have RC6026, and this hybrid has a really prominent central spike with a couple of very vertical branches to it as well. And this is nothing more than just a phenotype that, so an appearance that we see in the field, but it is something that you can start to see that expresses itself in the plant architecture. And so we see hybrids that may have more vertical canopies compared to those that may have more prostrate or laid out canopies. And that really expresses itself nicely as you get later and later into the season and see it as you're walking down the row. With those wide canopies that spread out, those hybrids may do really, really well in wide rows. They shade the row really nicely, or at low populations where they can capture as much light as possible coming down to the ground. But those vertical canopies are what the industry has been breeding for since the late 1960s and into the 1970s, because that vertical canopy allows light to penetrate more deeply into the canopy at higher and higher populations. So back in the 60s and 70s, we were planting corn at about 18,000 plants per acre across the United States. Today, there are parts of the country that are over 40,000 plants per acre, and you have to have that vertical architecture to see it. Now, plant architecture, peduncle architecture, how vertical things are, those aren't the only things that we see as differences in corn. We also see color differences. So you may see some color differences in the plants themselves, but one of the most fun areas to look for would be in the actual silks of the corn itself. So you go from a really yellow silk that you might see on some hybrids to other hybrids where, if they get enough sunlight, we'll start to have silks that turn anywhere from a salmon, kind of a pinkish purple salmon, all the way to a dark, dark purple that we see. That just shows how much anthocyanins, so a specific type of compound in the plant that helps fight off fungal infections, and that shows up as purpling in the plant. And once we start to take apart these ears, so pull them off, we can see what the ear will start to look like. So if we take an ear that's like this, we see inside of there is a developing ear shoot, or a developing ear, where we can see the structure of what that ear is going to look like later on in the season. So this is an ear of RC6026. It's 110-day with a really long, straight ear that's really attractive in the field. And this can be compared to another hybrid that would be RC6411, where it's not quite as long of an ear, but may develop more kernel depth and more girth to it than what we see in 6026. Also, we can note that this hybrid is a lot less straight of an ear than what we see in RC6026. And so you get a little bit of a curve to it. And some people in the industry like to call that the yield curve. And so why does all of this matter to the farmer? I mean, it's not really that big of a deal if you have purple silks or yellow silks on a hybrid, but what is a much bigger deal is having diversity on the farm. And so if you think about it, there's several ways you can get diversity. There's diversity of maturities, so you can have different hybrids that flower and black layer at different times, which help mitigate the risk to the farmer during heat stress or rain events throughout the season, allowing some hybrids to take more advantage versus others. We don't know when that rain is going to come, so having a broad set will help out mitigate that moisture stress. And then also, we have the genetic diversity package where some hybrids may be favored under certain environments relative to others. So if we think about 2024, and so far what we are seeing in 2025, we had a lot of moisture early in the season. Well, some hybrids tend to do really, really well with lots of moisture. And so those would be a lot of our power core and list hybrids that we have, RC 5859, 6026, hybrids of that nature. 5263 is another good example. And where they had good moisture throughout the entire season, they were able to take advantage and really yield with top-end yield. On the other hand, years where we may be dry early and get late rains, that may favor hybrids such as RC 6131 or RC 5768, where we have hybrids that really put on a lot of kernel depth late in the season and require good moisture to have that happen. So planting a little bit of each on the farm really allows farmers to diversify their germplasm or the genetics that they have to take advantage of or mitigate risk of any of the different environments that we may see in a given year. So that's why genetic diversity is so important on the farm.